Thank you. Thank you. Okay. So your presenters this morning, myself, my name is Wendy Garland. I'm an environmental data scientist at CEDA. Mark Pritchard is our JASMIN's operation manager, and Ag Stevens is head of partnerships. Okay. The CEDA team, what is CEDA? Well, we're the Centre for Environmental Data Analysis, and we are part of STFC. We're based in RAL space, but we're also largely funded by the NERC, the Natural Environment Research Council. There's about 30 of us. We're a mixture of data scientists and software engineers. And we have experience in Earth observation, atmospheric science, and data standards and that kind of thing. Here is a picture of us, taken a little while ago when we were actually allowed to meet back in 2019. That's what we look like these days, really. It's a bit more familiar to us all. Okay, so we're part of STFC, a research council, but we're also part of the NERC as part of the Environmental Data Service. This is a group of 5 data centers covering different subject areas, and CEDA covers atmospheric and Earth observation data. The other data centers you can see listed here cover different areas of environmental science data. All our data can be accessed through the data search portal, one portal for all of NERC data. At JASMIN, what do? We have CEDA, we have 2 key services. We have JASMIN supercomputer, a platform for intensive computing with local storage, and it works alongside the CEDA Data Archive. We have a very large amount of atmospheric and Earth observation data, 18 petabytes currently. And the beauty of having the CEDA Archive alongside the JASMIN platform and you can access CEDA data from JASMIN, is it avoids large scale data transfers. Okay, that's who CEDA are. And now I'm going to give you some examples of some of the air quality related data sets that we hold in the CEDA Archive. And my first example is the Facility for Atmospheric Airborne Measurement, or FAM. This is a research aircraft, a Boeing 146. It is completely fitted out as a flying laboratory. It flies around as a flying laboratory, sampling in situ air quality, cloud physics, meteorology. To date, we have over 1,200 flights from FAM from 2005 to the present day. Okay, on this page, I put I'll move my mouse. There's a brief indication at the bottom of the access you can get to the data. In this case, there's a brief registration required. It's open to all. I just show you on this slide, actually. Oh, sorry, beg your pardon. This picture down here. This is a flight finder tool, which is very handy for moving platform data. This is just a tool that allows you to find flights based on their flight path. So if you're looking in a specific geographic area, you can use that tool. I'll show you more about that later. More traditional ground-based observations, and we have many data sets in our archive. We have the NCAS, the National Centre for Atmospheric Science, AMOF observatories. AMOF is Atmospheric Measurement and Observations Facility. There's several laboratories and observation platforms for AMOF, and these have been running for quite some time, many years, long time series of air quality data. Also involving project work and other observations. So they're a very good source of air quality data. We have a few other observatories that are not run by NCAS, the Penley Point Observatory data. And we have the DEC Tall Tower Network. There's 4 sites at present. These are atmospheric composition measuring instrumentation on tall towers. Most of this data is freely available to registered users of CEDA. My next example, we have project data. These are measurement campaigns, usually for a short duration. We have many in our archive. Here's just a few listed here. You can go away and have a look for more. We also have airborne projects, airborne research projects, more in situ sampling. I mentioned earlier that FAM aircraft, a flying laboratory. Well, FAM is the UK aircraft, the main UK aircraft. Throughout Europe, there are a whole fleet of more than 20 aircraft also kitted out with various levels of instrumentation. We have a lot of data from their projects in our archive. I like this data set. It's one of my, the aircraft data is one of my specialities, and it allows me to put lots of pictures of aeroplanes in my talks. Okay. More air quality data. We have currently running the Manchester, Birmingham and London super sites running for the Oscar project. And these are measuring more than 40 species at each site, very similar equipment at each site so that there can be correlations and comparisons made. We don't have this data at CEDA yet, but we do expect it in the near future. We're currently in talks with the team. The data will be standardized and provided in a similar way to the NCAS Observatory's data. And so we don't have the data at CEDA yet, but it's coming soon, but you can currently access it through these websites here, regional authority databases. If you want more global coverage, we have satellite data. CEDA is also the data center for Earth observation data. One of the biggest of these is the Sentinel fleet. We have vast quantities of Sentinel data arriving daily. More information can be found in the CEDA website. Sentinel 5P is probably the most appropriate for the air quality community. Launched in 2017, it has global coverage and approximately daily resampling rate. We currently have about 10 petabytes of data from Sentinel satellite. So that's huge volumes. Petabyte is 1,000 terabytes. You can imagine you don't want to be moving that data around too much. So that's one of the beauties of having it alongside the JASMIN platform. You can access this data without having to do massive transfers of data. With your air quality measurements, you might need to look at the meteorological component. We do also have a great deal of meteorological data sets from the Met Office and from ECMWF. Met Office, we have observation data, MIDAS data set, and we have model data. We have numerical weather prediction data. From ECMWF, we have the ERA data, if you want to look at past analyses. All of this can be accessed through JASMIN as well. Right. Another data set we have is the CCI Climate Change Initiative data, ESA Climate Change Initiative. This is Earth observation data sets, including greenhouse gases, aerosols, other things that are applicable to air quality. We do host the CCI data portal, which is linked there, but the data is also available through the CEDA Archive. If you want to look at your air quality and use future predictions, we have UK climate predictions, we have data from the Coupled Model Intercomparison Project, or CMIP, and these are IPCC scenarios of future events. All of these are available through CEDA and JASMIN. CMIP 6 data is currently about 2 petabytes, so again, very large quantities of data. It's best if you don't have to move them around too much. Okay, this slide, this is data we don't have at CEDA. An awful lot of the National Air Quality Network data and Environment Agency data is available through the UK Air database. Now, we don't have any direct connections with these. I'm just putting this slide in here because many of you might want to use this sort of data. Now, whereas we don't have direct access to it, there is no reason at all why you can't go and get this data yourselves and bring it onto the JASMIN platform to use, and use it also with CEDA data or just by itself. You'll have to go and get it yourself and bring it to us though. Okay, so there is a flavor of the data sets we have. I say there's many more in the archive if you go and look for them. I've picked out those I think is the most relevant. How do you get to this data? I'll talk you very briefly through how you can access this data through the CEDA catalog. Okay, so to find CEDA data, go to the CEDA webpage. This is our CEDA main page. This has information about the CEDA archive, the JASMIN services, and news and events. Okay, if you were to choose the CEDA archive, this is CEDA archive webpage, and it has all sorts of information that you'd expect about the archive. In particular, the search catalog tab at the top here. This brings you to our catalog search, and you can put in a search term in the box here and search for it. It'll bring you up a list of relevant data sets. And now, as you can see, we have many different catalog records for our data sets. We have information about the data. We also hold metadata about the projects they were collected for, because that's often very useful information. The instruments, the people, how data sets are connected to one another, and collections of data sets. So if you notice down here, all these different icons, they relate to different catalog records we have, all matching the search term. I should also point out at this point, we have our search beacon here. This appears on the top of all the web pages on the CEDA site. Very useful link for getting extra information from our help documentation. So that appears on all the sites. You can go to their help pages from any of our web pages. Now, if you're to click on your data set, it'll take you to a record for that particular project. Now, this is a data set page. This is all about one particular data set. It gives you a title. It gives you a description of the data. It gives you the geographical and temporal extent, the authors, and a citation string. This is very important if you use your data in a publication, as you need to be able to cite it properly. If the data has been issued with a DOI, a digital object identifier, this will also appear here. Also from this web page, you have many links to different catalog records connected to this data set. You'll have information of how it was made, the instruments used, the site, the location. You'll see the list of the variables included in the files, a link to the project, and many other information. Tools on how to download are also available here. Up at the top of the page, you have any access constraints that might be applied to this data set. In this case, it's open. And here is your link to download the data. If you download the data, it'll take you to a web page like this. Now, this isn't the exact same one, but this is just an example of Wayborn data. And we have a file directory. This is our data browser. We have files and directories, and that's how our data is arranged in the archive. In the URL of this page, it's here. I've blown it up bigger so you can see it. You have, this is our server, and then this is the path of the data. If you want to use your data on JASMIN, you need to take a note of this path here, because that's how you would access the data from JASMIN, as if it's on the same file server. We have here a little button, which is an easy way to copy this file path for future reference. I'll just point out here our file arrangement. The top level directory is called BADC. This is just legacy. CEDA is merged several years ago now from the BADC, the British Atmospheric Data Centre, and the NERC, Earth Observation Data Centre, and a few other data centres merged into the Centre for Environmental Data Analysis. So this is just legacy from that time. Okay, so from here, you can navigate the directories to find out particular data you want, you can download it. There's a few other services available to subset or access the data that way. You download it to your own machine and work on it there, or say if you remember the path, you can access it via JASMIN. So that's the main way to search for your data through the catalog. For mobile measurement platforms, for example, the aircraft or satellite, sometimes it's very hard to know where the data is actually measured, what the coverage is, because the platform itself is moving. If you have a fixed site, a ground-based observatory, the observatory doesn't move. You know where it is, you know where you're measuring. But on an aeroplane, it could be flying anywhere. This is a picture of it's 1 year's worth of fan flights covering a vast geographical area. And there's no point looking for, say, data in the North Sea if the aircraft was over the Atlantic. So we have these two other search mechanisms. We have the Flight Finder tool for aircraft data, and we have the GeoSearch tool for satellite data. If you want to find a satellite seen over a particular area, it's very useful for that. So they're just two other ways you can search for the data. Once you've got to this point in your search, either for a flight or a satellite scene, you can just click on the scene. It will take you to the data browser like this. Okay. Right. So I've given you a flavor of the air quality data sets we have in the archive and how to find the data. I'm now going to pass over to my colleague, Matt Pritchard, who's going to give you an introduction to JASMIN. I'm going to stop sharing my screen and hand over to Matt.
Thanks, Wendy. Right, so I'll just try and share my screen now. It should be this one, I think. Hopefully you can see that okay. Yeah. Okay, so I'm going to give you a brief overview of JASMIN to talk about the purpose, what it's for, some of the services that make up JASMIN, and just a quick walkthrough of some example sort of user stories, user routes, if you like, through the system with examples of what you can do. Also talking a little bit about how resources are organized, and then Ag is going to follow on after me to talk about how to actually use, how to get started and how to use JASMIN. So we're only really scratching the surface of things really today. It's worth saying there's quite a lot of training materials and help documents which we'll link to at the end of these talks. For those of you less familiar with JASMIN, this is just a quick recap about what it's about. Really, it's all about supporting large-scale data-intensive science. And it's about enabling data analysis at the scales and with the performance that's required by the community in this particular science domain. So analysing large data sets is a big part of environmental science these days. So we need to provide the resources to do that. And as Wendy's mentioned, we've got access to the CEDA Archive. The CEDA Archive is actually hosted from within JASMIN. It's one of the sort of tenant projects, if you like, on JASMIN. It happens to be the biggest one. But also JASMIN enables you to bring in data from elsewhere and share that data in project and community workspaces. But also it's about providing some flexibility with compute capabilities to match what people need to do in their own workflows. So if you like, this is the model which really underpins JASMIN. The A in JASMIN, the acronym was originally for analysis. I think the rest of it has kind of got lost in the mists of time. But at its heart, it's all about the ability to bring your compute and your data together in one place. And it's also the element of sharing and bringing different groups of people together and their ideas. And that's really the concept of the group workspaces, which we can see here. This is a key concept in the sort of JASMIN landscape. And these are sort of dynamic user-managed areas of storage, so distinct from the CEDA curated archive. So the group workspaces are dynamic and user-managed. you can bring your data there, you can share it with your fellow researchers, and that's where you would kind of do your work. And the data can be worked up within those workspaces, and it's also a convenient place from where data, once it's ready, can be ingested into the CEDA archive. So altogether, it makes a very sort of convenient sharing environment. And as Wendy's mentioned, having the CEDA archive sitting there, means you can just access it in place, so you don't need to move it around, and that's increasingly important with the size of the data sets that we're using in environmental science these days. So how do we provide these kind of capabilities? So JASMIN is focused much more on storage and compute for data analysis rather than being a pure number crunching supercomputer, like, for example, the new Archer 2. So, Archer 2 would be maybe where you would run your big models, and you'd perhaps bring the output of those to JASMIN to compare them with observations, do your analysis, and that's a typical kind of scenario. So in providing somewhere to do that, it needs to be flexible and support a wide range of workflows and a variety of scales too. So in order to do that, it is a platform that's designed and operated by STFC on behalf of NERC, with responsibility for the different parts split between CEDA. So CEDA resides within the RAL space part of STFC, but the other half of JASMIN sits within STFC's scientific computing department. So if you like, we kind of jointly architected the system, but then it's the scientific computing department who look after the operation and the maintenance of the physical infrastructure of JASMIN, while CEDA, the CEDA team, looks after the user-facing services part of things. So these are our services kind of grouped together by type. It's always been a bit of a challenge to try and represent JASMIN as a picture. This is one of our latest attempts. And this one sort of lays out, as I say, the types of service, and we've color-coded them. So we've got information services like the help desk, documentation, access services, so the kind of top layer, how you get to various things. So we've got the accounts portal, login nodes, transfer nodes. Then there's the analysis compute. So that's the sort of compute services where you would do most of your analysis work, types of storage, and some other bits and pieces as well. So those are the types of storage. Then how do we arrange those together into the service that you might start to recognize? So we've got the information services still over on the left there. But this is how things are laid out. And if you're a user of JASMIN already, you might recognize some of these components. But I thought it might be helpful just to walk through a few different kind of perspectives. So this is one user story. So using the accounts portal, user can make themselves an account. And this is just like a profile which various privileges can be attached to. One of those privileges is called JASMIN login. So this gives you a system account which allows you to log into, first of all, one of the login nodes. And from there, you might then access one of the interactive compute or scientific analysis, or SCI, we call them for short, SCI nodes. And that has a stack of software, which Ag's going to talk a little bit about, which is shared between those SCI nodes and also the batch compute. We have a large batch compute cluster called Lotus, and that's currently got about 11,000 cores, sorry. So that's the compute part of things. Building up, you can build up a sort of working environment within your home directory, which is provided for you, but you might also belong to one or more group workspaces. So these are typically between about a terabyte or several hundreds of terabytes in size, and most users belong to at least one or two group workspaces. So that's where the sharing and the collaboration mostly goes on. Talk a little bit more about group workspace resources later. As I say, they're a sort of key part of the landscape here. So perhaps once the user has developed and tested their own code, maybe on one of the SCI machines, worked out how to run it on the batch cluster, might want to make use of the shared Scratch storage, along the way, perhaps because they need some feature of that storage, and obviously you need to clean up after yourself in terms of freeing up the storage for that to be usable by other people. And they might copy the output back to the group workspace where they can share it with colleagues, share the output and do any further analysis from there. So that's one story. In the second user story here, we're looking at moving data around. So we might be pushing data to JASMIN from some external data source. So we talked about bringing in data from a supercomputer like Archer 2. So we've got these data transfer nodes. These are kind of everyday ones at the top here. There's also some high performance ones in a special area of the network, which is sort of specially designed for large scale high performance data transfer. So it helps with some of the bigger transfers that do still need to happen. And there's also some storage which helps with this as well. There's a thing called the transfer cache. So this provides large scale kind of temporary self-provisioned space, perhaps more than you've got available in your group workspace, but you're only going to do some initial manipulation with the data, move the data away from there, and it helps, again, sort of helps make best use of the storage resources. There's also various other storage services like tape storage, and we have a service called the JDMA, or Joint Data Migration app, which helps move data between different storage types, disk and tape. So that's also available. And then they can get on with the task, probably in the same sort of managed part of the environment in the orange zone there. So the third story, this could be users who've evolved their workflow, having worked previously as per the last slide, but now they want to kind of try and develop a bit more of their own specialist platform. Maybe they want to share some of their results with a wider user community. So they like what they've seen in the managed environment of JASMIN, but now they want to build their own sort of services using building blocks that we've provided in the JASMIN cloud environment over here. So they can use the cloud portal to administer their own portion of the JASMIN cloud, their tenancy, and they can deploy virtual machines, specific virtual machines, or another offering is what we call the cluster as a service, or CAAS. And this offers essentially a set of building blocks built on top of the cloud environment. So things like Pangeo, which includes some sort of bits of toolkits like Jupyter, so you can run your own Jupyter Notebook service. There is actually a Jupyter Notebook service in the managed environment as well, but you might want to build your own one, perhaps customized in some way. And there's various other building blocks in that service which allow you to assemble the particular services that you need for your particular needs. So if you like, this represents a kind of general evolution from the interactive and batch computing in the managed sort of zone here to having some more advanced tools like the notebook service, to having custom things in your own part of the JASMIN cloud. So you can make your own mini JASMIN, if you like, within an external tenancy there. There are some challenges with data access. There's some basic services which allow access to the kind of secure data resources in the managed zone, but those are evolving too. That's part of our kind of roadmap. So just moving on. I seem to have missed a slide somewhere. Resources. Okay. So I had another slide which maybe I omitted to put in, which is about how the resources are organized. So we essentially divide the community up into roughly science domains, and within those domains we have a consortium manager who's well placed to know the sorts of requirements that community has, and it's that person, the consortium manager, who would get the overall allocation of a share of JASMIN resources for that particular community. And they would liaise with PIs or managers of projects within that community who might request particular resources on Jasmine, notably kind of disk space or cloud tenancies, that sort of thing. And there'd be a negotiation there as to what resources are needed and what's available, tensioned against other resources within those communities. So if you like, there's a divide between the management of Jasmine resources in the community and the management of your own project once it's on Jasmine. Which, if I manage to dig out the diagram, I'll perhaps add it onto the end of Ag's talk once he's finished. So at that point, I'll hand over to Ag, who's going to talk you through a bit more about how to use Jasmine.
Thank you very much, Matt. Just to check, you can hear me okay, Matt?
I can hear you loud and clear, Ag, yeah.
Excellent. And I will attempt to share my screen and just confirm that you can see that as well.
All good.
Okay, brilliant. Okay, so I'm Ag Stevens. I'm the head of partnerships at CEDA, and I'm just going to give a brief overview of the kind of next stage in the story, which is what does it actually look like when you're using Jasmine and some of the systems and services on there. So I'll briefly describe getting initial access and logging into Jasmine. I'll talk a bit about software that we've got on there. I will mention our batch processing cluster, which is known as Lotus, and then just spend a little bit of time mentioning our Jasmine notebook service, because I suspect, having had a bit of a look at the community, those of you that are out there in the air quality community, this might be an area that would be very useful to you in terms of how you could access Jasmine. So virtually all of these slides have a link at the bottom, and those links take you through to our help pages. Getting access to Jasmine, some of you will already know, and others may have heard, is a slightly convoluted process because there are lots of different components that you might need access to, and there are a number of things you need to do. So our help pages provide you with a step-by-step guide to take you through that process. And I really advise you to spend the time reading and understanding them, because in the long run, that will save you a lot of time. So it will talk you through things like generating an SSH key, which you will need to be able to log in, getting account details, and also checking things like your network details to make sure that the network you're logging in from can connect to the Jasmine network. It's all there in the help pages. So when you actually log in initially, most users will log in via an SSH terminal, and you'll be logging into a Linux system, but that is available from any external client. So you could be logging in from Windows, Mac, Linux, it doesn't matter at all. Each user is given a home directory with quite a generous quota, disk quota on it. And when you log in first, you'll typically log into a login server, which acts as a gateway to many of the other services that Matt was talking about in his talk. So for example, scientific analysis servers with appropriate software on them, our batch processing cluster, servers to do data transfer, and also in other cases, bespoke servers for specific services that you might be interested in. So for those of you that may not have too much experience of SSH and logging into a Linux terminal, this is just a quick view of what you would see if you looked in our help pages. So initially, most users will set up some kind of SSH agent, which allows them to load their SSH key. This is also all information that we tell you about in the help pages. And then you can log into the gateway server, which is called login one. And an important thing to note here is -A. Most of you will want to use this most of the time because this forwards your SSH agent credentials so that they pass through to the subsequent logins that you make. So here we've gone into login one. This gives us information about the available resources on some of the different scientific analysis servers. And from there, we can log in directly to one of those. And then typically users Once they're on an analysis server, they might load certain software packages. So here we're loading a software environment that I'll tell you a bit more about in a minute, and then fire up whatever language, whatever tools that they're working with. So in this case, I've just created an interactive Python session, and I'm loading in some third-party libraries that are very commonly used in our community. So that's one view of things. So let's talk a little bit more about software. And so our help pages again talk you through the different types of software available. So one of the things is that we've tried to make a core of open source analysis tools available on all our scientific analysis servers and on our Lotus batch cluster. But there are also tools for compiling and building software yourself, because you may want to install software that we don't already provide. And there are some restricted software tools that you can get access to if you have access to certain services. An example of that is the access to the MetOffice mass storage tape system, which we have a client for on JASMIN. And then there's also server-specific software in some cases, and software installed for data movement, and I'll mention that in another slide. So the primary data analysis packages, there's a lot of Python and Python packages that are installed, and these things are grouped into separate environments. And we're using a package manager tool called Conda that allows us not only to have lots of different packages available, but also different environments running in parallel. So that we can have a Python 2.7 and a Python 3.7, for example. We also have some packages installed via other means, such as RPMs, where they weren't available using Conda. And some examples on the right-hand side here are the kind of packages that are readily installed and any user can access. So that includes the R language and things like the NetCDF operators. So I mentioned data transfer tools. So any of you familiar with a Linux operating system will know that tools such as SCP and rsync are available as standard, and they are perfectly appropriate for copying small files or doing quick transfers between JASMIN and your remote system. So you might be either pushing or pulling files to or from JASMIN. If you have greater requirements, so if you're shifting terabytes of data around, you might look at our dedicated transfer server and some more sophisticated tools such as GridFTP or Globus Online. But an important thing to note is that on JASMIN, when you're logged in either via the SSH access, the SSH terminal, or via a Jupyter notebook, which I'll talk about in a minute, the data is already on the file system that you are logged into. So in many cases, you do not need to copy data at all. Once you log into JASMIN, the CEDA Archive is available to you. It's not all open access. Some of it you'll have to apply for access, but a lot of it is open access, and you can directly read the files from the archive without moving any data at all. And there are some links here, so you can pick up a copy of these slides and follow up some of these things on the help pages. So I mentioned a few times this batch processing cluster, and Matt also mentioned it. So Lotus is available for those people that are doing sort of larger scale and big data processing. So if your processing or your workflow is going to run for a long duration, or is complex, or has very high memory requirements, for example, you should typically be looking to run it on Lotus. And so Lotus has over 400 compute nodes, somewhere in the region of 13,000 compute cores, and there is a scheduling system known as Slurm, which you can submit your jobs to. And there are a number of different queues that allow for different types of jobs, such as those needing access to very high memory or running on multi-processors. If you're very new to all this stuff, it's unlikely you need to think or worry about Lotus. But if you develop into building complex workflows, it's definitely the way to go. So I mentioned that I was going to talk about the Jasmine Notebook service, and I'll just give a little demo of a Jupyter Notebook. So for those of you that don't know, a Jupyter Notebook is an interactive programming environment, but it runs inside your web browser. So it could be run in Chrome or Safari, Firefox, Microsoft Edge, etc. And notebooks allow you to do a number of things. So you can define, edit, and run code inside the notebook. You can embed visualizations within the code to demonstrate what the code's doing. And I'll show an example in a minute. You can include comments and notes to document what each bit of code is doing. And notebooks are really good for being able to share your work with others. So if you put your work into repositories such as GitHub online, there are lots of tools that allow other people to run a notebook, maybe in the cloud, or to take it and run it on their own notebook service. So Jupyter Notebooks exist all over the place on the web, and they're very useful scientific tools. We've built our own notebook service that runs on Jasmine. And I'll just give a little demonstration of what a Jupyter Notebook looks like. So I'll just make this full screen so that you can get a good view of it. And I will speed it up slightly. So here we have the Chrome browser, and we're accessing the Jasmine Jupyter Notebook service. And as you can see, it looks like I'm in an interactive Python console, because I'm doing things like calling Python functions, I'm creating variables, I can import parts of the standard library, such as the math library, and I'm actually writing lines of Python or cells with number of lines in, and then executing them one at a time. So what's nice about this is it's quite a user-friendly environment, and it makes it very accessible because you're running it in the browser. So there I've just created a function, and I've called a function, but you can do a lot more with these. So you can create visualizations. So here we're importing matplotlib, which is a very commonly used Python plotting library. And when I ask it to create a plot for me, it actually goes away, talks to the server, generates the plot, and then renders it within this notebook. So it's a really nice kind of interactive Python, scientific environment. In our case, we're only running a Python notebook at the moment. So here we're getting more complex. We're now looking at data in the BADC and it's in the CEDA Archive. So that's data that begins /BADC. So this is part of the large file system that I said you had access to if you're using Jasmine. And so we've read some data from a NetCDF file in the CMIP6 data set. And now we're taking a slice in time within that data set. And this is squeezing out a slice into just a two-dimensional latitude, longitude layer. And we can ask to plot that. And it goes away and generates this very nice plot of global data. So all of that is just an example of the kind of thing you can do with a notebook service. And we would certainly recommend for many of you that might be a nice entry point into using Jasmine. So the Jasmine Notebook service, some of the key features are it's available to all Jasmine users. So once you have a Jasmine login account, you can get access to this. And it's maybe a more user-friendly interface than the SSH interface that I showed at the start. You've got a Python programming environment that you can access from your browser, and it has a set of data analysis tools already installed so that you can just work straight from there. And very importantly, it's connected to the Jasmine file system. So if you have access to group workspaces, which Matt mentioned at the start, and if you want to access data in the CEDA Archive, you can just read that directly into your Jupyter Notebook. So there are some links here with further information about notebooks. Just to mention very briefly, so I've talked about a number of things. There's a lot of things I haven't had time to mention. So there are also other languages installed on JASMIN, on the JASMIN analysis servers, and on Lotus, such as R, Jar, Perl, Ruby are available. We have IDL installed and a set of interactive and runtime licenses if you're an IDL user. There are some workflow tools such as Rose and Silk that allow you to manage big multi-step workflows running on Lotus. And there's also various community contributed tools. These include things like the Earth System Model Validation Tool and 2 packages here that are developed and managed by the Met Office. So that brings us to the end of the presentation. So just to say that there are a number of links here, and you could follow our link to our events where you can find out more about webinars, about training and other workshops that we are running. But I think that now brings us to question time. So I will hand you back, I think, to Wendy or Fleur to take over from here. Thank you very much.
Right. Okay. Thank you, Ag. Thank you, Matt. And let me have a look. If anybody has any questions, would you be able to put them into the chat channel, and we'll see if we can answer as many as we can. Let's give you a few moments to think any questions you might have. Oh, you're all very quiet today. Also, we welcome any suggestions for any future training you might need.
There's a question here from Juan. Can you use languages other than Python in the notebook service, e.g. R?
Unfortunately, at the moment, we don't have the capability to do that. So we have had interest in setting up Jupyter notebooks that support R. We just haven't been able to find the resource to invest the time to make that happen. So we know it's possible, and we appreciate that there's user interest. So, and thank you for requesting it, because that will add to the driver to make it happen. But at the moment, it's not yet in our work plan.
Perhaps while we're waiting, we can just mention about sort of further training. So we, for the past year or two, we've been running a series of JASMIN training workshops, and these are normally run over one day. They've been physical events so far, but we've actually been busy sort of adapting the material for delivering online, as we can't do a physical one at the moment. So if you're interested in a more kind of hands-on experience of learning how to use well, everything through from login servers, transfer servers, learning how to use Lotus, we cover the notebook service, and also just some of the more complex developing workflows and getting more complex workflows to work on JASMIN. If you're interested in finding out more about those, then just keep an eye on the both the CEDA news service, also subscribing to @CEDA News, and Poppy usually posts all the events that are happening on there. So when we know the date of our next training workshop, once we've got our materials sorted, hopefully we'll be able to announce the next one of those training workshops. So keep an eye out for those.
We have a question from Tom. I think it's probably for you, Matt. Can the group workspaces be organization specific, i.e. If we have data models we want to bring in that might be protected by IP, can we keep those elements private and only disclose information we want users to see?
Yeah, so the nice thing about group workspaces is that once they're set up, it's actually for you, the members of that project, to manage. So you control who is a member of your workspace, and similarly, being a member of a workspace essentially means having a particular Unix group associated with that workspace. You're sort of granted that Unix group. And you don't have to, but you can restrict the data that sits in that workspace to only be visible and only be readable and writable by members of that group. So that they're very much a kind of container that we give to a project that it's then there, that they can make it as private or as public as they want it to be.
Okay, thanks, Matt. I have another question. They're forecasting future air quality data on CEDA. I think that would be covered by the CMIP 6 future predictions, would it, Ag? I don't know if there are any specific air quality predictions. I'd have to look into that a bit further.
Yeah, I don't think I have the knowledge to respond usefully on that.
I'm not aware of any. That doesn't mean they're not there. That's a good question. Some very nice comments. Thank you. I hope it's been useful for you. We'll find some way to circulate the slides from today's webinar so you can follow the links and look at the help pages and the events links. We'll get those circulated to you somehow in the near future. Excellent. Well, I hope it's been useful for you. Again, if you have suggestions for any future training you might need, drop a line either if you think of it in the next minute or two in the chat box, or else you can always send it to the Air Quality Network team. All right. Are we able to send a link to watch the video back? Fleur, can you do that?
Well, yeah, well, I'm thinking if I've got the recording, I can probably make it available on the website, and then others who weren't able to make this session today will be able to benefit from it as well. And hopefully we can share the presentation slides on there as well to accompany it.
And yes, we'll make the slides available. Excellent. If we have no more questions, I think people are beginning to hop off the call. I think we should just say thank you for listening and stay safe.
Thanks very much to all the presenters.
Thank you, everyone.
Thanks, everyone.
Okay. Bye, everybody.
Bye.